Hey guys. Okay, so if you were part of the last video chat for this past week, you'll have a little heads up on this, but basically what we're doing is we're going to continue our knowledge with skeletons equations, and we're going to mesh them with our chemical reaction types so that we should be able to predict our products at the end, okay? So in this situation, you are always going to be given what you start with, okay? So you are almost usually always given it to it in names. So that means we have to take our name and we have to transfer it into our formula. We always need our states, and we're going to use all of those rules and things that we talked about when it came to skeleton equations, okay? So at the end of this lesson, you should basically be taking everything, yes, everything we've learned in chapter 3 and meshing it all together. Okay, so that means solubility, balancing, skeletons, reaction types, all in one. Okay, so to get going, I am going to take my formula, my name, and turn it into a formula. When we're doing this, we need to remember we have to balance our charges. There is no workaround for that. That is always the case. So we have potassium hydroxide. Okay. They both have a charge. Potassium has a charge of +1, hydroxide has a charge of 1 negative, so it's balanced. This is a base, so it is an aqueous state. It's an AQ. Ooh, it's a long Q. Okay, it reacts with sulfuric acid. So this is where our acid naming comes into play. If you're wanting some more help with that, let me know. I can do a quick recap mini lesson if you're needing it. No harm in asking. Nobody else will know that you asked. I'll just post it to the whole classroom. So when it comes to naming, we're using our naming chart. Okay, sulfuric acid. So that means I'm going with a hydrogen 8. So this should be H2SO4 because my acids still have to be balanced. And it isn't acid, so it is an aqueous state. Okay, so arrow, I know a chemical reaction is happening. So how do I know what my products are? This is where identifying my chemical reaction type is key. Okay, so I have a compound here and I have a compound here, which means that I'm going to identify this as a double replacement. Okay. So super important that you practice this before you even attempt to practice your chemical reaction types before you try this lesson. Okay, so a double replacement means, from our last video, that we are going to switch our cations. Our cations are our positive charged ions in our compounds. They are always wrote first. They are our metals. So these guys are going to switch in regards to what our products are going to be. So potassium is now going to be with sulfate. Okay. Now, the numbers here and what goes down in the bottom is not influenced by this side at all. Okay, it is influenced only by the charges. So potassium is 1 positive, sulfate is 2 negative, so I actually need 2 potassiums. Okay, I will check my solubility chart in order to figure that one out. So my state, so solubility, SO4, find my anion. Then I'm going to find potassium. Potassium is in my most, so therefore it is an aqueous state. Okay. And then the hydrogen is now with the hydroxide. So H, OH, and you should actually recognize that as something, a little familiar to you, called water. So this is in liquid state, okay? So there is our equation starting, products finished. The very, very last thing that you should be doing is balancing this guy. So that means the only thing I can do when I balance is to change, or not change, place coefficients, okay? So if I was to do this, potassium, I have 1. Hydroxide, I'm going to keep as a polyatomic. I have 1. Hydrogen, I have 2. And sulfates, I have 1. Okay. Potassiums, I have 2. Hydroxides, I have 1. Hydrogens, I only have 1. And sulfates, I have 1. So I am going to deal with my big guys first. So potassium. So this, I need to be a 2. Okay. That now has changed not my just potassiums, but it's also changed my hydroxides. Okay. So now I'm going to deal with my hydroxides next. So I need 2 on this side. I put a 2 in front of my water. This becomes a 2. And my hydrogen becomes a 2. And all of a sudden, balance, 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 balance. This is a finished, nicely balanced chemical equation. All right, let's give another one a go. So, magnesium reacts with hydrochloric acid. Okay? Arrow. States-wise, magnesium is an element. It's not diatomic, so it's just a solid on its own. Hydrochloric acid is an acid, so therefore it's an aqueous state. Okay, so identify what kind of chemical reaction's happening. I have an element and I have a compound. So this is a single replacement. Okay, so that means I'm going to identify what this element is. Is it a cation or is it an anion? Because it could be either. Magnesium is a cation, so it's a positive charge. So that means it's going to switch with the cation in the compound. Okay, so these guys are going to play a switcheroo. So that means magnesium is going to go with chlorine. Now, just like the last example, my numbers here in this compound depend strictly on the charges that are present. So magnesium is 2 positive, chlorine is 1 negative, so I need a 2 here. Okay. In regards to state, solubility chart, chlorine, magnesium, has solubility. This should be aqueous. Okay. And that leaves my hydrogen on its own. Now, our diatomics still come into play here. Because hydrogen is an element on its own, it has to be H2, and it is in gas state. Okay, last thing to do, balance it. If you want to try this, I'm going to just do the shorthand version. There should be a 2 right here. It will be balanced out. All right, so if you are wanting to try one of these, pause the video and you can try the third one here. If not, follow along. I will do at least one more. So we have magnesium and oxygen react. All right, so this is usually where I get people like, oh yeah, we're good. Nope, we're not good. Okay, magnesium needs a state. It's an element, so therefore it's a solid. I check my state of my elements by looking at my periodic table. What state is it in at room temperature? Oxygen cannot just be O, it has to be O2, and it is a gas. Now, careful. This has oxygen present, so sometimes I get people tell me this is a combustion reaction. It's not, and that's because there's no hydrocarbon present, okay? So a combustion only happens when oxygen is present, aka oxygen is burnt or something is burnt. But combustion means that it has to have hydrocarbons of CH4, CH3, C3H8, something with carbon and hydrogen. This case, you just have an element and you have an element, which means we are actually dealing with a formation reaction. Okay, So formation reaction means that I'm going to get one compound. They're going to mush together. So Mg and O, the numbers are strictly based on charges. Magnesium has a charge of 2 positive, oxygen has a charge of 2 negative, so therefore this is a balanced compound. And get rid of that, that's just my thinking. And then I check, surprise, surprise, my solubility chart to see how it's going. Okay, oxygen, not on here, so therefore this is actually a solid. Okay, balanced wise, I'd have to throw a 2 in front of here and a 2 in front of that guy. And that question is done. Yeah, I think I have one more. Nope, that's all I got. If you want me to do one more or want some more help with that, let me know. You guys will have some practice to play with this a little bit. And then next week, we're going to move on to moles and molar mass and finish our very last concept in chemistry. I hope you have a good rest of your guys' day.